About 13.8 billion years ago, there was nothing. No stars, no planets, not even bad Wi-Fi. Not even the empty space between your ears when you forget where you put your keys. It was a state of pure, unadulterated zilch. Imagine trying to describe the color of a sound, the taste of a number. For reasons our best science brains are still debating over very strong coffee, all the everything that would ever be was squished into a point smaller than a period at the end of this sentence. It was hot, it was dense, and it was about to have a very, very big day. This singularity was the ultimate cosmic firecracker, waiting for a match that didn't exist yet. About 13.8 billion years ago, bang! The universe didn't so much explode as it just expanded, rapidly, like inflating a balloon with all of time and space drawn on it, only way faster and without the risk of it popping in your face and scaring the cat. The Big Bang was the starting pistol for the cosmic marathon. In the first fractions of a second, the universe was a hot soup of fundamental particles, quarks, gluons, other things that sound like characters from a sci-fi cartoon. Then it became a slightly cooler, slightly larger soup. This cooling allowed those fundamental particles to get together and form the first stable building blocks of matter: protons, neutrons. It was like a cosmic singles mixer where everyone finally started pairing up. Within the first few minutes, these protons and neutrons began to fuse, creating the first atomic nuclei. Mostly hydrogen, a bit of helium, a tiny sprinkle of lithium. The universe was still a foggy, opaque plasma, a bit like trying to see through a thick London fog, but the stage was set for the next act. For about 380,000 years, this glowing fog was all there was. But as the universe cooled further, suddenly, the fog cleared. Light could travel freely across space for the very first time. This ancient light is something we can still detect today as the cosmic microwave background radiation. It's the universe's baby picture, and for a 13.8 billion-year-old, it looks pretty good. After the fog cleared, the universe entered what astronomers call the Dark Ages. It wasn't because everyone was listening to moody music. It was because there were no stars yet. There were just vast, silent clouds of hydrogen and helium. But these clouds weren't perfectly uniform. Tiny variations in density meant gravity could get to work. Gravity began pulling gases into dense clumps. Cores heated and pressure skyrocketed. It was the universe's first attempt at making anything more interesting than gas clouds. Pressure and temperature became so intense that nuclear fusion ignited. Hydrogen atoms smashed together to form helium, releasing huge energy. The first stars were born, lighting the cosmos and ending the Dark Ages. First-generation stars were giants, hundreds of times more massive than our sun, burning insanely hot and bright. They grouped together under gravity, forming the first galaxies. The universe became a glittering city of stars. But these stars started with only hydrogen and helium. You can't build planets or people out of that. You need heavier stuff: carbon, oxygen, iron. Stars cooked heavier elements by fusing helium into carbon, carbon into oxygen, and onward to heavier elements. Stars acted like cosmic forges, layered like an onion with iron at the core. How do those elements escape the star? It gets explosive. The core collapses and the star dies in a supernova. A supernova can briefly outshine its whole galaxy. The blast scatters heavy elements across space, from the calcium in your bones to the silicon in your phone, all forged in dying stars. So next time you argue about whether pineapple belongs on pizza, remember that the carbon in both the pineapple and the pepperoni was forged in the same kind of stellar explosion. About 4.6 billion years ago, in a quiet corner of the Milky Way galaxy, a new star began to form from a cloud of gas and dust left over from previous supernova explosions. This star was our sun. As gravity pulled the material inward to form the sun, the remaining dust and gas flattened into a spinning disk around it, called a protoplanetary disk. It looked like a giant, dusty vinyl record with a star for a spindle. Within this disk, tiny particles of dust started sticking together. It was a slow, patient process of cosmic construction, like building a Lego castle one tiny brick at a time. Pebbles, rocks, boulders, planetesimals, small rocky bodies hundreds of miles across. These planetesimals were constantly crashing into each other in a chaotic demolition derby. The winners grew bigger and bigger, eventually becoming the planets we know today. One of these lucky winners was a young, molten ball of rock we call Earth. Our planet had officially arrived, but it was not exactly a welcoming place. It was a hellish landscape of lava oceans under a sky pelted by asteroids. Early Earth was a terrible vacation spot. The surface was a sea of molten rock. The atmosphere was a toxic mix of gases you definitely couldn't breathe, and it was constantly being bombarded by leftover debris. It was hot, violent, and had zero amenities. Then, just when things couldn't get any crazier, Earth had a really, really bad day. A Mars-sized object, which scientists have nicknamed Theia, slammed into our young planet in a cataclysmic collision. This wasn't a fender bender. It was a planetary head-on crash of epic proportions. The impact was so immense it would have vaporized both bodies. This giant impact tilted Earth on its axis, giving us our seasons, a happy accident, and blasted a huge amount of molten rock into orbit. This ring of debris, like a temporary halo around our battered planet, eventually coalesced under its own gravity. It clumped together to form a new, smaller sphere. We call it the Moon. So our beautiful moon isn't just a nightlight. It's a cosmic souvenir from the most violent event in Earth's history. After the moon-forming impact, Earth was a molten mess. It began to cool down. As the planet cooled, water vapor began to condense and fall as rain. It rained for millions of years, filling the basins and craters, forming the first oceans. Earth was transforming from a ball of fire into a water world. The oceans were a chemical soup rich in dissolved minerals and organic molecules, a perfect primordial broth for something amazing to happen. Sometime around 3.8 billion years ago, in this warm, chemical-rich water, the first life appeared. We don't know exactly how it happened, but simple organic molecules began to organize themselves into self-replicating structures. These were the first microbes, simple single-celled organisms like bacteria and archaea. They weren't much to look at. No eyes, no brains, no ability to complain about Mondays, but they were alive. Some of them, called cyanobacteria, developed a revolutionary new trick: photosynthesis. They learned how to use sunlight, water, and carbon dioxide to make their own food. This was a huge evolutionary leap, but it came with a game-changing byproduct: oxygen. For the existing life forms, which had evolved in an oxygen-free world, this was a disaster. Oxygen was a toxic, corrosive poison that caused a mass extinction event for anaerobic life. This great oxidation event was the planet's first pollution crisis, but it was a golden opportunity for others. Some organisms evolved ways to not only survive in the presence of oxygen, but to use it to generate energy far more efficiently. Around 2 billion years ago, another major leap occurred. The first eukaryotic cells appeared. These were cells with a nucleus and other specialized compartments, the ancestors of all plants, fungi, and animals, including us. It was as if life had upgraded from a simple tent to a fully furnished mansion. For billions of years, life remained pretty simple. But then, around 541 million years ago, something spectacular happened: the Cambrian Explosion. It was as if life's creativity department, after a very long coffee break, suddenly went into overdrive. We see the first creatures with shells, exoskeletons, legs, primitive eyes. Fossils from this period show us bizarre-looking critters like the Hallucigenia and the Anomalocaris. Following this explosion of diversity, life began to conquer new territories. Around 470 million years ago, the first plants began to colonize barren, rocky land. Soon after, insects like millipedes appeared. Early scorpion-like arthropods followed them ashore. Meanwhile, back in the water, fish were evolving jaws and skeletons. One group of lobe-finned fish developed sturdy fins they could prop themselves up on. Those fins eventually evolved into legs. These brave fish amphibians were the first vertebrates to walk on land. This led to the age of amphibians, then reptiles, and eventually, the dinosaurs. For over 150 million years, these magnificent creatures dominated the planet, from the towering Brachiosaurus to the fearsome Tyrannosaurus rex. It seemed the age of dinosaurs would last forever, but the universe had other plans. The final score, giant rock, 1. Dinosaurs. 0. The dinosaurs' catastrophic end was a golden opportunity for our fuzzy, warm-blooded ancestors. With the giant reptiles gone, mammals came out of the shadows. They exploded in variety, evolving into giant rhinos, saber-toothed cats, bats that flew, whales that swam. Among these newly diversifying mammals was a group that took to the trees, the primates. Our distant primate ancestors evolved grasping hands, forward-facing eyes, perfect for navigating branches. They were agile, clever, and set the stage for the next big step. A few million years ago, in the grasslands of Africa, a group started walking on 2 legs. This transition to bipedalism freed up their hands for carrying food and, eventually, making tools. These early hominins, like Australopithecus, were pioneers of upright walking. Over time, their descendants developed bigger and bigger brains. Early humans like Homo habilis started chipping stones to make simple tools. Homo erectus learned to control fire. Armed with tools, fire, and growing intelligence, our ancestors began to spread out from Africa. They adapted to new climates, icy tundra, tropical rainforests. Eventually, our own species, Homo sapiens, emerged. We were social, we were curious, and we were great communicators, developing complex language. For thousands of years, we lived as hunter-gatherers. But about 12,000 years ago, we made another huge shift. We invented farming. This agricultural revolution allowed us to settle, build villages and cities, and, of course, invent taxes. From there, human history accelerated. We built pyramids, developed writing, and created empires. The scientific revolution taught us the laws of nature. The Industrial Revolution gave us machines to harness them. In the last century alone, we've split the atom, walked on the moon, and created a global communication network that lets us watch cat videos from anywhere on the planet. We've entered the Anthropocene, an age where our activities are the dominant influence on the climate and environment, presenting us with our greatest challenges yet. And through it all, our curiosity continues to drive us forward, to explore, to learn, and to create. From stardust to streaming services, it's been one wild ride. And we're still arguing about whether pineapple belongs on pizza. The grand story continues. The universe began with chaos, forged stars, built planets, created life, and eventually produced us, a species that can ask, where did we come from? While simultaneously debating pizza toppings.
Thank you for joining Strange Mystery World. If you find the video helpful, don't forget to hit like, subscribe to the channel, and turn on the notification bell to motivate me to create more videos and not miss out on the interesting things behind Strange Mystery World. See you in the next video.